Good morning all. Am I audible?
Yes, sir.
Okay. Shall we start? Shall we start? Hello.
Yes, sir.
As all of you may have received the instruction from college management, uh, again this offline mode is stopped right now. Again, everyone is expected to remain online. Since it started before few days, and we have started uh, offline lectures too. But when they are coming back to online, naturally there was a distance between an online lecture and an offline lecture. So, uh, in an online lecture, we were far ahead than that of offline method. So, to make that gap filled, what I have observed is we should start with again right from the beginning, right from the beginning in the sense example point of view, and we'll share few new examples so that for the person who were online right from the beginning, they may have little more practice, whereas the person who were offline, they may have this example for the first time, most probably. Today's lecture we have dedicated to the number of examples which we were likely to do. Are all of you set with pen, paper, and a graph paper if possible? Are you ready with pen, paper, and graph paper if possible?
Y- Yes, sir.
Then today we will try to have a little started from a scratch, and we will see all the examples starting from a graphical method and all. So try to focus much on example, and those who have already done such type of examples, they will be having a liberty, and they have to focus much on the speed instead of content itself. I am sharing screen sharing it with you, and we'll have examples, right? The last three lines. With the help of graph paper, obtain the trend values. Naturally, this example shows that with the help of graph paper. So naturally, a graphical method is to be used. Here and some values are given to you. 1996, 1997, 98, 99, 2000, 2001, and 2002. And the values are given 65, 85, 95, 75, 100, 80, and 130. What should be done to solve it with a graphical method? First thing first of all, you have to plot all these values on a graph paper. But as we know that in a time series analysis, whenever we are using a graph method, or you can say a freehand method, at that point of time, always, sorry, your x-axis is with respect to time. In this case, your time is in form of years, so naturally your x-axis will be year, and your y-axis will be a value which is given to you. Observe the row titled as year. It starts from 1996 and it goes up to 2002. So all these values, the lowest value which you have is 1996 and the highest value which you have is 2002. So on a graph paper, the lowest left hand side, very near to a point of origin, it should start with 1996, 96, 97, 98 and so on. The second row is value. In this row, just observe which is the lowest value. The lowest value in this row.
65.
65 is the lowest value. Similarly, the highest value in the row,
130.
which is 130. So your y-axis should consist these 2 points and all the points in between. So you can put y-axis accordingly, starting it from 65, and it should go more than 130. Then only you'll be able to put all the points on a graph paper. Right? Let us see how thing works. Look. This is how this graph shows. First of all, put all the points. While putting all the points, if you connect it with dots, it will be little zigzag type of a graph. And that graph is known as actual trend. Means actual data, or you can say actual trend. Once you draw this freehand graphics, the second thing is to be done is you have to draw a best fitted line. What is this best fitted line? The best fitted line is, the first option is that it should consist maximum number of points. But all these points are little haphazard. It is going zigzag, so you don't have that option with you. So you have to draw a line where you should feel like 50% of the area should go upwards and 50% of your area should go downwards, and you have to put a line which is exactly in between of these two. Here, the line which is shown as a dotted line, means with dots, that line is called a trend line. And this is how this example is to be thought of, is to be solved of. Are you getting the same type of a graph?
Yes, sir.
Fine enough. Let us shift to the another example. Next example. Draw a trend line by the method of semi-average. As you know, we have already seen it, that in a semi-average method, one thing is very important. The data set given to you. Here, year and cells in thousand is given to you. Starting from 1993 to 2002 data set is given to you. Okay. First thing to be observed while using a semi-average method is how many entities are given to you. How many data set is given to you. It's a 10-year data. Since 10 is an even number, so you can divide the whole data set in two parts, 5 years each. So 1993, 94, 95, 96 and 97 will be the first set of data. 98, 99, 2000, 2001 and 2002 will be a second set of data. Put a line in between. While you put a line in between, so you will be able to justify that it is the first group and the second would be the second group. Now, the first group, there are 5 years, so make a bunch of that 5 and the respective cell, whatever may be the entity, you have to sum it up for the 5 year. So 210 plus 200 plus 215 plus 205 and 220. What is the total of it?
1050.
1050 is the total of first 5 year cells, right? Okay, that 210, so 1050 divided with 5, what you will get is 210, and that should be written exactly in between of these 5 years. Exactly between of this 5 year is 1995. So 210 is to be written against 1995. Perfect. Similarly, make a second group. The second group consists of 1998, 99, 2000, 2001 and 2002. Exactly in between 2000 comes in picture. And the entities are 235 plus 210 plus 235 plus 225 plus 245. While making a sum of this 5 entity, total comes to, what is the total?
1100.
Which is 1150. Since we have summed 5 elements, so you have to divide it with 5. Ultimately, it comes 230. This 230 is to be written against the middle year. The middle year is 2000 in that case. Right? Now, you have to plot all these points on a graph paper. As you did it in the earlier method, first thing is to be done is plot all the points which are actual on a graph paper. While putting it on a graph paper, again year starts from 1993 and goes up to 2002. So your x-axis should consist 1993 to 2002. Similarly, your y-axis, what is the lowest value in cells?
200.
200 is the lowest value and the largest value is
245.
245 is the largest value. So you have to keep in mind that your y-axis should consist these 2 points, 200, 245. Okay. Take the scale accordingly. Now, put all the points on a graph paper and connect it with a free hand. So again, what you will have would be a zigzag type of a graph. Do it. And that zigzag graph is titled as actual trend, from which the second thing is to be done is to get a trend line. Now to get a trend line using this semi-average method, now you have to plot 2 points. Which are these 2 points? To draw a line, minimum number of points you require are 2. So 2 points are to be plotted to draw a trend line. These 2 points are, look, the thing which we have calculated, 1995. Against 1995, the point is 210. So plot this point on a graph paper. 1995 on x-axis and 210 on y-axis. Put a dot, put a point there. Plot it on a graph paper. Similarly, and another point, the second point is to be plotted, which is 2000, and against 2000 the calculated semi-average is 230. So this 2000 on x-axis and 230 on y-axis. Wherever the junction comes, mark that point. Now these 2 points are to be connected with a dotted line. Now connect this 2 point with a dotted line. And that line is called a trend line. Are you getting such trend line?
Yes, sir.
That's great. So this is what exactly the semi-average method does. If you compare these two methods, graphical method and then semi-average method, the only difference among these two is, in a graphical method you were having liberty to draw a trend line. Means whatever comes in your mind, your judgment was the ultimate judgment. Whereas we try to fix that, because if everyone is allowed to draw a line on a graph paper, no two lines may remain same. So there are chances of error. To eliminate those chances of error, the method which we have enhanced is a semi-average method, in which again 2 points are to be taken care of. It is to be plotted on a graph paper and connecting that line. Now you can observe that all of you will have the same trend line, and that was the basic object of using this semi-average method. This example we have seen it when total number of years given to you are even numbered. What happens when odd number of years are given to you? What happens when odd number of years are given to you? In that case, you will not be able to split your whole data in two parts. Since you will not be able to split your whole data in two parts, naturally something is to be omitted. Now you have three different options with you, whether you will be eliminating the first entity. The second option which you have is, if you can eliminate the last entity, or the third option is you can eliminate exactly the middle entity. You just think of it, which entity is to be eliminated to make even number of data so that you can split it in two parts. What should be the judgment? If you eliminate the first entity, then you are losing certain data. If you are eliminating the last entity, again you are losing certain data. And in statistics and mathematics, losing data is not a good sign. So we took a decision that the exact middle year is to be eliminated off. So for a moment, let us suppose in the same example, one more entity is given to you as 2003. Then what should be done? Make a total number of years are 11. The nearest even number is 10. Divide the whole thing in two parts. While dividing it in two parts, naturally first 5 year and last 5 year and whatever comes as a middle year, that entity is to be eliminated off. Right? And do the same process as you did it with this simple average method, semi-average method. Let us have one more example. Semi-average method, here number of entities given to you are 7. Year 1996, 97, 98, 99, 2000, 2001, 2002. Total number of entities given to you are 7, which is not an even number. Since it is not an even number, naturally you have to, an elimination process is to be done in this case. The nearest value which is even is 6. So you have to make a bunch of 3. So first of all, make a bunch of first 3 years, 1996, 97 and 98. And the output units accordingly, respectively, output units are 600, 800 and 1000. So 600 plus 800 plus 1000. What is the total?
2004.
1400.
2400. Divide it with 3, what you will get is 800. 800 is to be written against the middle value. The middle value is 1997. Fine enough. Now make a bunch of last 3. Last 3 are 2000, 2001 and 2002. And the respective quantities are 1200, 1000 and 1400. While making sum of these 3, what is the total?
3600.
3600 is the total. Divide it with 3, what you will get is 1200. Naturally, you could observe that one of the value which is in between of these two group having output as 800, that is to be eliminated, or they are left out, you can say, which is exactly the middle item. Now things are same. Plot all the points on a graph paper, connect it with freehand, so you will have the zigzag graph. On an x-axis, the lowest value is 1996, the highest value is 2002. All these points should be on your x-axis. Similarly, y-axis. On a y-axis, the lowest value is 600 and the highest value is 1400. So all these points should be on y-axis. Once this x and y axis are fixed, now put all these points, inclusive of that left out. Every point is to be written, every point is to be plotted, and you have to connect all those points with a freehand graphics. So you will have this zigzag type of a graph. Once you do this zigzag type of a graph, name it as actual trend. Now, you have to plot 2 points, the point which you found using semi-average method. this 800 which you found, which is written against 1997, so 1997 and 800, this point is to be plotted, is to be shown on the graph paper. And the second point to be plotted on the same graph paper is 2001 and 1200. Now, connect this 2 point with a dotted line. When you connect this 2 point with a dotted line, that line becomes a trend line. Are you getting a similar type of a trend line?
Yes, sir.
That's great. So we have taken care of both the methods, semi-average. If an even number of data is given to you, you don't have to bother about it. You can divide the whole data set in two parts. And if an odd number of years are given to you, or odd number of entities are given to you, at that time, the nearest even number, the lower nearest even number, that is to be taken care of, and a middle item, whatever comes in middle, that item is to be eliminated, or you can say terminated, and then use the same logic as you were using it with semi-average with an even number. And you have to plot a graph, points on a graph paper, and you have to connect it to get a trend line. Is this method okay? I mean, are you in a position to do it of your own now?
Yes, sir.
Fine. Let us
Yes.
move ahead. Now we are shifting our focus to moving average method with an example so that this will be little easier for you. Okay, the following figure relates to the profit of a commercial concern for some number of years. Find 3 yearly moving average. Two data sets are given to you. One is in year form and second is rupees, or you can say profit in rupees. And these are the actual values. Fine enough. First thing is to be done is, first of all, in the same you have to rewrite the data set in column format. The first column is to be drawn is of year. The second column is to be drawn is profit in rupees. Just write it down. Then after, make another column named as 3 yearly moving total. 3 yearly moving total. What is to be written in this case? In the 3 yearly moving total, what we have to do is we have to make a bunch of 3 years. So 1995, 96, and 97. The corresponding profits are 15,420, 14,470, and 15,520. You have to make an addition of these three, and you have to write it against exactly what is there in middle. In middle it is 1996. So against 1996 you have to put the sum of 15,420, 14,470, and 15,520. What is the total of first three profit in rupees?
45,400.
45,410, and that entity is to be written against 1996. Fine. Now, how you will get the second entity? To get a second entity again
The
now, yes, please.
Skipping the first element.
First year or first entity is to be eliminated and again make a bunch of three. Now making a bunch of three, it comes to 1996, 97 and 98. And the profit in rupees comes to, respective profit comes to 14,470, 15,520 and 21,020. While making sum of these three, what is the number?
51,010.
51,010. That should be written in between of 96, 97 and 98. So in between comes to 1997. So you have to write that 51,010 against 1997. To get the next element, first 2 years are to be eliminated. Again make a bunch of three, 97, 98 and 99. 15,520, 21,020 and 26,120. While making sum of these three, total comes to
62,660.
what is the total?
62,660.
$15,520 plus 2120 plus 26,120. What is the total?
62,660.
62,660. Have to write it against middle year. The middle year is 1998. And you have to proceed with the same logic and try to get all the sums of profit making a bunch of three. What is the next entity after 62,660?
1,02,996.
Which was the last one, right? After 62,660, the next entity is 79,090. Next of it is 93,440. And the next one is 1,02,990. Now you just observe that against the first year and against the last year there is no value. So put a dash there. So in a column, while making a 3-year moving total, always your first entity will be dash and the last entity will be dash. Now make another column named, title it as 3-yearly moving average. To get each of this entity, naturally the first entity is dash, so dash will remain there. The next entity against 1996 is 45,410, which is a sum of three entities. To get an average, it is to be divided by 3. So 45,410 divided by 3, it comes to 15,136.66. And if you just make it round off, it comes to 15,137. Similarly, 51,010 divided by 3, it comes to 17,003. And similarly, you may be able to get all the values, which is 3-yearly moving average. simply divide all the entities, which is 3 yearly moving total column, divide it with 3. What you will get is 3 yearly moving average. Are you getting all these values now?
Yes, sir.
Yes, sir.
Fine. Can we shift to the new case? The next case, rather.
Yes, sir.
Okay. The next example is find the centered 4-year moving average from the following data set. Years and output are given to you. Since this 4 is an even number, here you have to follow a two-step method. In this two-step method, and another word is used here, and that word is centered. So that centering process is to be done in a second phase. Things will remain as it is. Now, instead of making a bunch of 3, since it is a 4-yearly moving average, you have to make a bunch of 4. First thing first of all, rewrite the data set in column format. But whenever 4-yearly moving average is to be found, what I suggest is put a line, a blank line in between of each of the year. So 1995, a blank line, 1996, a blank line, 97, a blank line, and so on. Put a blank line in between of each of the year. And accordingly, write the output. It is needed to put a blank line in between of everything just because of you will come to know while making a sum of it. Now, make a bunch of 4. While making a bunch of 4, 1995, 96, 97, and 98. The output are 30.1, 45.4, 39.3, and 41.4. Make a sum of this 4. What is the sum?
156.2.
156.2. That entity is to be written exactly in between of these 4 years. Now look, in exactly in between of this 4-year means it will come somewhere between 1996 and 97. You have kept a blank line between 96 and 97, so you have to write this 156.2 exactly in that blank line. Similarly, the next point, skip the first year and make a bunch of 4. So 45.4, 39.3, 41.4, and 42.2. While making sum of this 4 entity, it should be against the middle year. Against middle year in the sense that middle year will come somewhere in between of 1997 and 98. What is the sum?
168.3.
168.3 is a sum, and you have to write it in between of 97 and 98. Do the same thing till the end. What is the next entity?
169.3.
169.03. Okay. What is the next?
176.3.
1
76.3.
76.6. Is it 6 or 3? Just check it out.
3.
Okay. What is next?
184.4.
184.4. Now you can observe that you made the bunch of 4 everywhere, right? For every entity. The next column is 4 yearly moving average. Since it is a 4 yearly moving average, you have made a sum of 4 entities. So naturally, you have to divide it with 4. So whatever is there in this column, 4 yearly total, divide it with 4, you will get a next column, which is 4 yearly moving average. So 156.2 divided by 4 comes to 39.05. Similarly, 168.3 divided by 3 divided by 4, comes to 42.08. And similarly, you have to divide each and every entity by 4 to get all the entities on the next column. Just get it and let me know what are the points. 39.05 is the first one. Second one is 42.08. What is the third one? 'What is the next entity?
42.33.
42.33. What is next?
44.15.
44.15. What is next?
46.1.
46.1. Now you just observe all these entities are coming in between of 96 and 97, 97 and 98. So naturally one more process is to be done, and that process is called centering. So make a new column, 4 yearly moving average centered. Now what you have to do is making a bunch of 2, make a sum of 2 and divide it with 2 and put it exactly in between. So what will happen in this case? Look, the first entity is 39.05 and the second entity is 42.08. Make a sum of these two. While making a sum of these two and divide it with 2, what you will have would be 40.57, and you have to put it in between of these two. In between of these two is nothing but against 1997. Similarly, the second point, 42.08 plus 42.33, make a sum of these two, divide it with 2, that becomes 42.21. You have to put it in between of these two, which is against 1998. This process is called centering process. Do it for all the elements. What are the entities? The first entity is 40.57. What is next?
42.21.
42.21 is the next one. What is next?
43.24.
43.24 is the next. What is next?
45.13.
45.13 is the next one, right? Actually, while observing, you can observe that if a 4-yearly moving average center is to be found, in that case, first two entities will be dash and the last two entities will again be dash. Is it okay?
Yes, sir.
I think now
Yes,
you
sir.
know it quite well that how it is to be described, right?
Yes, sir.
Okay, I am moving little faster now. Just again, these are the sum of 3-yearly moving average and 4-yearly moving average. This type of data you have already done it, and we want to move little faster. So I am directly coming to 5-yearly moving average now. Read the last line in this paper, in this page. Calculate trend values by taking 5-yearly period of moving average for the following data. And this is a data set given to you. Starting from 1987, 88, 89, and so on up to 2002. And production in ton is given to be some entity 4, 5, 6, 7, 9, something like that. First thing is to be done is put it on a column format. So your first column would be year, second column would be production in tons. Since our interest is to get it a 5-yearly moving total, and then after 5-yearly moving average. So in the 5-yearly moving total, make a bunch of 5. 1987, 88, 89, 90, and 91. Whatever the production you need for this respective years are, which is 4, 5, 6, 7, and 9. Make sum of this 5 entity. Put it against exactly the middle year. While adding 5 elements, naturally the middle year would be 1989. So you have to put the sum of first 5 entity against 1989. What is the sum of 4, 5, 6, 7, 9? Is it 31? Are you getting it as 31?
Yes, sir.
Okay. Now skip the first one. Skip the first year. Again make a bunch of 5. So it would be 5 plus 6 plus 7 plus 9 plus 6. What is the total?
33.
33. Do the same for all the entities by skipping one more year, and so on. The first entity is 31, the second entity is 33. What is next?
33.
33 again. What is next?
34.
34. What is next?
35.
35. What is next?
33.
33.
What is next?
33.
Again 33. Next.
36.
36.
36. Next.
38.
38. Next.
40. 40.
40.
40.
40. What is next?
40.
40 again. What is next?
43. 43.
43.
43.
What is next?
20.
Now you will not have, because you don't have an option of making a bunch of 5. Right? Okay. Now observe it. First two entities. Whenever you are dealing with 5 yearly moving average, first two entities will be dash and the last two entities will again be dash. Make another column, title it as 5 yearly moving average. This 5 yearly moving average is nothing but whatever total is there, you made a sum of 5 entities, so you have to divide it with 5. So 31 divided by 5, it is 6.2. 33 divided by 5, it is 6.6, and so on. Means whatever is there in column of 5 yearly moving total, divided with 5, what you will have would be 5 yearly moving average. Is it perfect?
Yes, sir.
Find it and let me know the entities. The first entity is 6.2. What is next?
6.6.
6.6.
6.6. What is next?
6.6. 6.6.
Again 6.6. What is next?
6.8.
6.8.
6.8. Perfect. Next.
7.0.
7. Perfectly okay. What is next?
6.6.
6.6. Right enough. Next.
Again 6.6.
Again 6.6. Perfectly okay.
7.2. 7.2.
7.2. Next.
7.6. 7.6.
7.6. Perfectly okay.
8.
8.
8.
Again
Again
8.
8. Right.
8.6.
And
8.
8.6 would be the last one, and 2 dash. This becomes a 5 yearly moving average for the given data set. Perfectly okay?
Yes, sir.
So I think now all of you are comfortable with this sort of data. Our type of data, all of you are very much comfortable with, right? We'll keep it up to this. All other examples will have it in the next lecture. Any question?
Sir, can you give more examples for least square method?
List square method, we haven't started it yet, and you will have plenty of examples when we start it.
Okay, sir.
List square method, we haven't started it even in online mode. We haven't started this method. But whenever we will start, we will have plenty of examples of this type. Method of least square, there are two types in that case. One is linear and second is quadratic. So in both type of examples, we will have many examples doing it in a classroom. So don't bother about, right? I think now our time is up. Thank you. Thank you for your time. We'll meet at the next lecture now.
Thank you, sir.